Hello and welcome back to the lab. Today on the bench we have something. It is an HP something, 8165 programmable signal source, 1 millihertz to 50 megahertz. Nice frequency range. And it looks like we have sine, triangle, and square wave. No ramps, but that's not necessarily a problem. And we can do some sweeping, a couple of other things, external modulation, and some neat issues. The tag that was on this said bad A6 connector, so I don't want to apply power before I take a look and make sure we're not going to do anything too crazy. So usually we do a power on test, see what kind of signs of life and everything we've got in the unit. In this case, we're going to take the lids off, take a look at this. Is it A6 for an IC? Couple other things. If it's just an IC socket, that's not going to be near a problem. We'll just get that replaced and it won't be a big deal. Given the fact that it's on my bench, it's probably going to be a little bit more catastrophic than that, but we will find out in a little bit. Let me reposition the camera. We'll get the lids off. We'll get the lid off and take a quick peek. Here we are. Looks like this A6, this is going to be the board of choice. So let's see what we have going on. And looks a little rough, but not too bad. Let me pull the board out and let's get a closer look. Pull the A6 board out. These 3 screws on the back come off. This metal plate pops up. And here's our board. That's going to be not great. There was almost no pressure on that connector. Oh, that's not good. Well, that's going to need fixed. All right. This is a 44 pin, sorry, 22 on the side, 44 pin connector. That interfaces A6, one of the 2 connectors of A6 to the main board of the unit. Our first challenge is swapping this connector out. For once we get lucky, all the pins are accessible just by removing the bottom cover. I do need to re-straighten this rail up here. There's a decent bend. This took an impact on the side, bent that out, so there is a little bit of chassis work on this unit we're going to have to do. But I got to get in here with a desoldering tool and get all these pins removed. I'm going to take a soldering iron, wet the pins to alloy some fresh solder in there, and then I'm going to go in with a desoldering tool and pull all the pins out. The soldering tool is set to 650 degrees Fahrenheit. The desoldering tool is beefed up and it's set to 750 to get the holes to clear out a little bit better. Just so happens the lab has a socket connector. That should be a suitable replacement. So we'll take a quick look, compare them once I pull this out, and make sure that'll be an okay replacement, and go from there. So let me get this pulled out. Well, I'm feeling better and better not trying to power this thing up when I first got it, because the whole front panel's disconnected. What? Okay, this unit may be a mess. Going in, I'm going to have to reseat this board, get some connectors, so the front panel's going to have to come off. Wow. I really don't know how this is going to go, but I am rapidly getting the feeling this is someone else's parts unit that was just tossed back together and launched into the pile. But we'll give it a go, get it put together, see what happens. Okay, so that's the logical place for the connectors to go, following the cable paths. The front panel is still connected and everything looks okay there. Next stop is to get this board back in the face, but I need to clear the power button. As I work down the board this way, the board's going to kind of preheat in front of the iron because I'm pushing the heat further this way along the PCB. So as I work and the board warms up, I'll be able to work faster and faster and faster. It also helps with the desoldering tool to get the solder to melt, because this is a pretty substantial pin that goes up into that connector. For the solder that we're using good old-fashioned leaded solder. Alloy is a 6337. Don't really use any of the 6040 stuff anymore once I used it all up. The 6337 freezes better than the 6040. The 6040 has a kind of plastic region where the joint's not quite frozen and can still move around, and you can get goofy solder joints and things like that with it as the joint's cooling off. The 6337 has a much quicker liquid to solid freezing curve. Okay, good desoldering tool. And here we go. That's it. That's how quick the holes clean out. I'm going to do that for the rest of them. I won't bore you guys by watching me just desolder 44 pins. And I'll bring you back when we pry the connector off the board. All right. Let's see if we can get this out without pulling out any of the plated through holes. That would be fantastic. Oop, it's coming. Plastic gave on the bottom, which is fine, and that one looks all right. None of the through holes came out, and everything looks good. Yeah, board looks okay. All right, so inside of one of these connectors, all it is just pins folded over, coming out the bottom. So these were TRW cinch 2230 301. I have some 2230 300s, which should be just fine. Yeah, it looks like it's going to be all right. So this is the connector we're going to go in with. These are pulls. I've scrapped these out of some other units that weren't repairable for various reasons. But that is going to pop in quite well. Awesome. These connectors are still attainable. The lab just has some in stock. They are like, well, when I recorded this, they were like 20 bucks a piece. So definitely something, if you have a unit with a bunch of them that you're scrapping out and you have a good desoldering tool, worth the time to desolder them. And soldering is just the reverse. The soldering iron is set to 650, and it just hit it because of the beep. This needs to be over here. That doesn't look bad. One of the things that a lot of people don't talk about with the process of soldering is the diameter of the solder used. I have a couple of diameters, but thinner is better. You can always add more by just flowing more solder into the joint, but it can be really hard if you have a big, thick roll of solder to control how much is going onto the joint. So this is 0.8 millimeter solder. And I use this roll quite often in the lab. I have some stuff that's thinner for when working on surface mount, things like that. For this, if I was using the thinner stuff, the like 0.3 or 0.37, I'd feed in, it feels like you feed in a mile of solder to get the joint at a decent level. Part of the reason these specific pads are taking so much is filling up the through hole. There's a flat tab. There's not a big lead going through the through hole, so filling that up takes a fair bit of solder. Not too bad, though. Gonna want to get all the flux off of here once we're done. But this is a no clean flux, which essentially means doesn't ooze everywhere. Doing this with the normal iron and the iron set to 650, but I'm a fan of the Heiko FM203. It lets me actually solder pretty quickly. This is a 70-watt handpiece. I'm debating because the FM203 is close to getting discontinued. They came out with a new line. So one of the nice things in the new line is it's got N2 in the micro. So I'm thinking about bringing in the next version, because I don't want to say this is a great iron, everything's wonderful with it, and then nobody can get it because it's discontinued, which happens quite a bit in the repair world. So I want to be evaluating and using stuff for you guys that's attainable at the time of recording. So let me know what you think in the comments if I should bring in the next version of the Heiko, especially with the N2 in the micro. I do have a nitrogen soldering setup, but you guys have to tell me what you want to see in the comments. And just like that, we have a rebuilt connector. Let's get the board slotted in, and then we'll see if we can't figure out why this ended up in the junk box. Here is our A6 board. Goes in this way. Gonna need to find the board guides now because we have a good connector. All right, that grabbed real nice, lined up real well. Going to get the back plate put back on because that actually holds some of the boards in place, keeps them from flopping around in the breeze. I don't expect any arc over or anything like that out of this power supply. I don't even know what output level this thing puts out yet. I have to look at the spec chart. But I think we're ready to apply power. Okay, I've got everything hooked up into the power meter. This does have a linear supply, so I could potentially and probably should start it up on the Variac and isolation supply, but we'll give it some go and see what happens. Lab's running about 124 volts RMS. And that started really quickly. Unit's drawing about 140 watts. But I don't see any magic smoke. And we have some stuff on the display, so... Oh, wait. Nope. There's some signs of life. Okay. That should be 1 kilohertz, 1 volt at the output. And it does look like we can enable the output. So let's throw it on a scope and see what happens. The switches in the keyboard need to be cleaned, but let's see what we get. Now let's kick on the output and see what happens. This is 1 volt, and it does say we're in 50 ohms, but we have sine waves. Let's see about triangle. Yep. Square. Yep. 20%, 50%, 80% duty cycle. That looks good. We're going to do internal sweep. Frequency start. Or wait, start sweep. Sweep stop. Yeah, it looks like it's sweeping. That's a 10 hertz to 1 kilohertz sweep. So the way it's acting, it's showing me that it doesn't have a blanking sweep. So what's happening is it's sweeping from low to high, and then it's sweeping from high to low. So some of my other units, they only sweep one way. They have a blanking sweep, so it'll sweep one way, and then it'll blank, and then track back, and then sweep again. This one's not doing that. It is sweeping both directions, which is fine. So I guess the next step is I got to look at a spec sheet and see what this thing even can do, because there's lots of adjustment points, and it's throwing errors and a couple of other things. So I got to figure out. Definitely need to get some contact cleaner in the keyboard. It's a little crusty. But I think we're sitting about 80%. All right. Well, I've got the control boards out. And HP could not make up their mind with how they want to design this thing. I've got LEDs next to incandescent light bulbs. We've got the HP buttons, which they're very well known for. They're known for having problems, but they're also known for cleaning easy. You just got to get some contact cleaner underneath the button. The problem is this metal spring, that's just the spring tension for the button. That is not the contact for the button. The contact for the button is actually on this side. So we'll get all those cleaned up. And then we have the front panel with the numbers, which is even yet a different style of button, more reminiscent to the HP calculator style of button. There's some channels going up and down, and then a metal plate that just gets pushed against the contacts to close the circuit for the button. Foam's completely dead and degraded. Normal in gear of this vintage, the foam's turned to almost slime. And made in Germany, which is kind of cool. Not a lot of stuff coming out of there at the moment. But got to get all these contacts cleaned up and go from there. We're going to clean all these boards. Wanted to pop them out to do it. Where I like my job so much, I have to do it twice. So we got started. We made some LEDs with current limiting resistors to replace the grain of wheat light bulbs in the indicators. Weird mix on this unit of LED and grain of wheat. Not sure exactly why HP decided to go that route, but here they are. I initially started with a 2200K resistor, half watt, and that just ended up being way too large. The LEDs stood proud of even the indicator LEDs, and I need them to be further into these sockets. Another indicator that this panel has some time on it is we have some yellowing on the plastic from the heat of the grain of wheat bulb that was in there. So it's nice to switch these out to LEDs. I had some 2000 ohm precision resistors that were quite a bit smaller, quarter watt instead of half watt, so recessed them more. So I had to pull all the LEDs out, change the resistors, put them all back in. Polarity-wise, this large trace right here is the positive, and it's a common positive to all the indicator lamps. So that helps with the orientation of LEDs. I put the resistors in the negative end of the LEDs, so the resistors are on this side, pointing this direction, except for the error indicator, which is backwards and points that direction. So with an LED, polarity is important. I'm almost ready to get this put back in the chassis. I still have to fix this one button. I'm waiting on the delivery man to drop off some shim stock, spring steel shim stock, so I can cut a new spring for the switch. When we do that, I think we can put the display to bed and say this board is at least repaired. What's going on with startup on this unit is there's no batteries in it. The board that sits behind this in the unit is supposed to have 2 batteries in it, and they are not present. That is making the signal generator lose its volatile memory. So as when the power goes out, the RAM just kind of goes out to lunch. Well, when it starts up, all that RAM just randomly picks a state. So every bit in that memory module picks a state and nothing resets it. So it gets in some wild states, things like that. And that's why we have all the error lights and everything like that when the unit powers up. It looks horrific. It's not actually that bad. So that will probably be easily fixed with a battery. I do wish this was YouTube was a bit touchy-feely, but the switches, both here and the calculator push-button style switches, they cleaned up very well. And these feel like a proper control again instead of crunchy and mushy and full of junk. So a properly functioning switch and control, there's a feel difference to them when they're working right and when they're not working right. So these are feeling much better. The front panel that sits here is also feeling a lot better after cleaning it up and getting all the contacts cleaned up. We are missing one of the springs for this button still, and that's the shim that I need to cut. But we'll wait for the delivery, and then we'll be back. All right, the shim stock's here, and it is what I ordered, but it's not what I want. So I ordered an assortment of shim stock because I kind of needed some here in the lab anyway. It's blue temper, 127 millimeters, which is a little thick, 0.005 inches. That's a little stout for a spring. It's about double the thickness of the spring itself. So it's holding the button up, and I can actuate the button, and it works. But it's a little stiff, and over time, I don't want it to eat through the plastic. So I've ordered another batch of shim stock, which should be here with even thinner pieces than this, because this is the thinnest piece in the assortment that I ordered, so it just gets thicker from there. But I can reassemble the front panel, and we can work on calibrating and troubleshooting and things like that, because now this switch won't fall closed and just sit closed. So let's get the panel reassembled. We'll fire it up. We'll test the lights that we put in, and we'll see where we are in terms of a troubleshooting standpoint. All right, so what I thought was broken was actually functioning by design. The high impedance output on this particular unit does not function below 2 volts. So if it's below 2 volts, has to be terminated into 50 ohms. Not a problem. Also, it looks like the problem that I had with the output, probably because of how I had it set up, isn't there. It's a phantom problem, so if I went after it, I'd be chasing my tail. I took a sweep from 1 millihertz all the way up to 50 megahertz with a 5-volt output, and it did not lose the waveform. It didn't go nuts. Everything worked exactly the way I would have expected it to. So at this point, other than a couple of miscellaneous ancillary things, the switch on this button and a few other things, this unit I think is ready for calibration. I do want to replace a couple of capacitors on here. There's a couple of small ones that need to come out. But I think we've done enough work for this video, and we'll prep it for calibration. Also, let me know in the comments below how you think we should take care of that battery issue. Because right now, with the SRAMs dying, every time you power it on, it's completely lost its mind. I have to go through. I have to set everything up. I have to zero everything out. and it's not saving state at all. So not a fault, but a nuance and something I know about without batteries. So I'm going to look in the service documentation as well, see what they recommend to do about batteries, and we will go from there. Thanks for stopping by the lab and taking a look at the 8165 repair. There was a lot wrong in this thing. It definitely it took some work to get it up and going. So, but if you like what you're seeing, hang around, hit the subscribe button, like button, all the bells. Give a shout out to the patrons of this channel. They help make videos and keep things coming up to YouTube. Their support helps me keep the lights on in the lab and have videos coming for all of you guys. So thank you again to everybody who supports the channel. It helps way more than anybody thinks. If you'd like to support the channel and get some early access content, take a look at the Patreon page. Patreons are running ahead when it comes to YouTube videos. So there is nothing behind the paywall. Everything will eventually make its way to YouTube, at least for now. But as of the time of this recording, that is still true. But they are running several videos ahead. So if you'd like to take a look at that, swing by, let me know what you guys think. As always, I read all the comments in all the videos. So in between videos, I will see everybody in the comment section. If you have a suggestion or video ideas, let me know down in the comment section. A lot of videos on the channel have been from viewer comments and requests. So we'll see what we can get recorded. As always, more's on the way, and I will see everybody in the next video.